Welcome to the deep dive. Today, we're tackling a really core question for anyone involved in manufacturing. What's the best way to create precise holes?
Yeah, it's something that comes up a lot.
Exactly. So, if you've ever been weighing up, whether a dedicated CNC drilling machine is your best bet for consistent accuracy, or maybe if a more versatile CNC machining center is the smarter path, well, you're in the right place.
Mm.
We've got this really insightful article that digs right into this specific comparison.
It does. It lays it out pretty clearly.
And our mission today is really to cut through some of the jargon, define the strengths of each technology specifically for drilling, and just give you that practical knowledge you need.
Yeah, help you choose the right approach for what you're doing. It's not just like two machines that can drill holes. We're going to explore the sort of fundamental design thinking behind them.
Design thinking, how so?
Well, how those design choices actually translate into, real world performance differences when you're trying to make accurate holes. It's about focus versus flexibility.
Okay, let's unpack that. So, the article points out pretty quickly this key difference. A CNC drilling machine is really a specialist, right?
Totally. Its main job, its primary function, is making accurate holes. Usually that means moving the drill just along one axis. Think focused power.
Focused power, I like that. Whereas a CNC machining center, that's more the Swiss Army knife of the machine shop.
Exactly. Good analogy. Yeah, it drills, but it also mills, taps, bores, often moving across multiple axes.
And that multi-axis thing, that opens up way more complex shapes, doesn't it? Three-dimensional stuff.
It absolutely does. But what's interesting, as the article notes, is that even though both use CNC control, their different design priorities give them distinct advantages.
So the dedicated drilling machine, because it's built just for that, it can often hit a higher level of precision just for the holes.
Often, yes. It's optimized for that single task. The machining center, while it's incredibly versatile and useful, trades some of that hyper-specialization for doing lots of different things.
Okay, got it. So CNC drilling machine, it's not just one single thing then. The article mentions there's actually a whole range of them.
Oh, yeah, definitely. It's a category, really.
Yeah.
Different configurations for different needs. You've got things like upright drill presses, radial arm drills, gang drills.
It's quite a list.
It is, and understanding these is pretty crucial. Take the upright drill press, often geared.
Geared, meaning high torque, lower speeds.
Exactly, high torque. So it's
Yeah.
robust, a real workhorse, good for heavier, larger parts. Sometimes the operator can even sort of assist feeding the workpiece. It's a traditional design, just, updated with CNC.
Okay, dependable. Then you mentioned the radial arm drill press. That sounds more flexible.
It really is.
Mm.
The spindle head moves along this adjustable arm, so you can cover a big drilling area on a workpiece that stays put. Really useful for bulky parts where moving the part itself is a hassle.
Ah, so you don't have to reposition a massive casting just to drill a few holes on different sides.
Precisely. For shops doing low volume, high variety, large parts, it can be way more cost effective than trying to wrestle those parts onto a big machining center.
Makes sense. Okay, what about a gang drilling machine? The name sort of implies teamwork.
Hey, yeah, that's a good way to put it. You have several fixed drill heads all lined up over one work table.
Ah, okay.
So you can do multiple drilling operations either all at once, which cuts cycle time way down, or one after the other sequentially without moving the part.
So for parts needing a line of holes, maybe?
Perfect example.
Hmm.
Or any pattern where the spacing is critical. Doing them without moving the part minimizes those positional errors between the holes. Super important for assembly later on.
Right. And you mentioned something similar, multiple spindle drilling machines. Is that different?
Similar concept, different execution. Here you've got several spindles, but they're all driven by one head, and they all feed into the part together.
So drilling lots of holes in a pattern simultaneously.
You got it. Think high volume production. If you're making thousands of parts with the same pattern of, say, bolt holes, this is a huge time saver.
Okay, big stuff, fast stuff. What about the other end? Tiny things.
Yeah, that's where the micro drill press comes in. Engineered for really extreme accuracy on tiny components.
Like in electronics?
Yeah.
Or medical stuff.
Exactly. Think circuit boards, connectors, tiny medical implants. They use incredibly small drill bits, tiny chucks, super precise controls.
Wow. Okay, one more. The turret type drilling machine. Turret? Like on a lathe?
Similar idea, yeah.
Yeah.
It has this rotating turret that holds multiple tools, not just different drill sizes, but maybe taps for threading or reamers for finishing a hole really precisely.
So quick tool changes?
Super quick.
Yeah.
Makes it efficient if you need to do several steps on the same hole. drill it, then tap it, then maybe countersink it, all without stopping to change tools manually.
Okay, so that's a lot of variety just within drilling machines.
It really is. And the takeaway, like the article stresses, is that your choice really hinges on the job. Part size, accuracy needs, how many holes do you need, sequential ops, all that stuff matters.
Right, so we've got a much better handle on the machines themselves now. But the article also goes deep, like really deep into the drill bits.
Oh, absolutely essential.
It makes the point that just grabbing any old bit isn't going to cut it with CNC.
Couldn't agree more. That drill bit is where the rubber meets the road, or rather, where the tool meets the material. It is the cutting tool.
And using the wrong one leads to problems.
A whole cascade of them. Poor hole quality, slow speeds, the tool wears out fast, or it could even break catastrophically, which can damage the part, maybe even the machine.
Ouch. Okay. So beyond the standard, twist drill, HSS, high-speed steel, there's a whole world of specialized bits.
A huge world, engineered for specific materials, specific tasks.
The article has a great table. First up, it mentions carbide-tipped or solid carbide drills. What's the deal there?
Okay, so carbide is much harder, much more wear-resistant than HSS. These are your go-to for tough stuff. Stainless steel, cast iron, composites, things that just chew up HSS bits.
Because they last longer.
Much longer. And you can run them at higher speeds. Yes, they cost more upfront, but in hard or abrasive materials, they can last like 5–10 times longer. Saves on downtime, saves on tooling costs in the long run.
Makes sense. Okay, next. Brad point bit. I think I've used those for wood.
You probably have. That sharp center point and the little side spurs, they're designed specifically for precise starting in wood. Some plastics, too. Stops the bit from wandering.
Gotcha. What about a step drill bit? Those look kind of like little Christmas trees.
Yeah, they do have that conical shape with steps.
Yeah.
They're for making different sized holes in thin materials, usually sheet metal, without changing bits. Just drill deeper for a bigger hole size.
Handy for electrical boxes or panels, maybe.
Exactly. Saves a lot of time. Then there's the center drill. Very short, very stubby looking.
Right, what's its job?
Its job is to create a super accurate starting dimple, like a pilot spot, for a larger drill bit. Because it's so short and rigid, it doesn't flex, ensures the bigger drill starts exactly on center, prevents walking.
Yeah. Positional accuracy. Okay. Oil hole drills. Do they actually have holes for oil?
They do. Internal channels that run right down to the cutting edges allows coolant, oil, or synthetic to get forced right to the tip.
Why is that so important?
Crucial for deep holes. Flushes chips out, cools the cutting zone, reduces friction way down in there, really helps maintain accuracy, and prevents the bit from binding or breaking deep inside the material.
Speaking of deep holes, there are specific deep hole drills too, like gun drills.
Yep, gun drills are a classic example. Highly specialized geometry, often need high-pressure coolant systems. They're all about drilling very deep holes while keeping them incredibly straight and getting those chips evacuated effectively over a long distance.
Wow, okay. That's specialized. Then combination tools. Sounds like multitasking.
That's exactly what they do. Combine operations. So you might have a drill reamer that drills and then immediately sizes the hole perfectly. Or a drill tap that drills and cuts threads in one shot.
Saves tool changes, speeds things up.
Massively.
Yeah.
Especially in high-volume production. Fewer tool changes mean faster cycles. And finally, profile drills.
Profile, like shaping the hole.
Sort of. They have shaped tips to create things like countersink, so a screw head sits flush.
Yeah.
Or a counter bore, which is like a flat-bottomed recess for a bolt head. Creates the final form in one go.
Okay. And it's not just the bit type, is it? The article mentioned coatings and flute design, too.
Oh, yeah, critical details. Coatings like tin, TICN, TALN, those add hardness, reduce friction, resist heat. They can dramatically boost tool life and let you run faster, especially in certain materials.
So the coating needs to match the material you're cutting.
Ideally, yes. And the flutes, those spiral grooves, their shape matters too. A parabolic flute helps pull chips out of deep holes better. A straighter flute might be better for brittle materials that make small chips. It all impacts chip evacuation and how smoothly it cuts.
Man, it really is a whole system. Choosing the right bit seems every bit as important as the machine. Pun intended, maybe.
Yeah, it absolutely is. You could have the best machine in the world, but with the wrong bit, or run with the wrong speeds and feeds. You're just not going to get the results you need. It's a partnership between the machine and the tool.
Which brings us nicely to the next bit. The key considerations for effective CNC drilling. It's clearly more than just having the right hardware. There's a whole process, right?
Exactly. Getting those consistent, high-quality holes efficiently. It needs a holistic view. The article hit several key points, starting with material selection and compatibility.
Understanding what you're cutting.
Absolutely. Its hardness, how easily it machines, does it work harden when you cut it? All these properties dictate your tool choice, your speeds, your feeds. Metals, plastics, composites, they all behave differently.
And that flows right into optimal tool selection, which we just covered. Matching the bit material, geometry, size, coding to that workpiece material, and the whole specs.
Check. Then comes speeds and feeds optimization. You mentioned this earlier, it's that balancing act.
Right. Spindle speed, RPM versus feed rate. How fast you push the drill in. Too slow is inefficient. Too fast breaks the tool or ruins the hole.
Pretty much. You want the sweet spot for good material removal, but without sacrificing the hole quality, the surface finish, or just burning up your drill bits. Start with the manufacturer's recommendations, then tweak based on how it actually cuts on your machine in your material.
Always fine-tuning. Okay. Related to speed is heat. Right. So coolant and lubricant strategy.
Essential, especially with faster speeds or tougher materials.
Yeah.
Need to reduce heat, cut friction, help chips clear. You've got different types: oil, synthetic, semi-synthetic, and different ways to apply it. Flood coolant, mist coolant, or that through spindle coolant we mentioned for deep holes.
Makes sense. Okay, something maybe more basic but fundamental. Rigid work holding. Fixturing.
Cannot stress this enough. Your workpiece must be clamped securely. If it moves or vibrates even slightly while drilling,
Accuracy goes out the window.
instantly. Position, size, finish,
Mm-hmm.
all compromised.
Yeah.
And you're much more likely to snap a drill bit. Good, solid fixtures are non-negotiable.
Okay. Then effective chip removal. We touched on this, especially for deep holes, getting the swarf out.
Crucial. If chips pack up in the hole, they generate more heat. They can jam and break the tool. They mess up the surface finish inside the hole. It's a major headache if not managed.
So techniques like peck drilling, where it drills a bit, pulls back, drills a bit more.
Exactly. Peck drilling cycles, like GA3 and G-code, break the chip and give it a chance to clear. Or using that through spindle coolant to actively flush them out. Very important.
All right. And then just good practice. Tool design and wear monitoring.
Yeah, pay attention to your tools. Check them regularly for wear, for chipping. Have a system for knowing when a tool is nearing the end of its expected life and replace it before it fails unexpectedly. Prevents scrap parts, prevents machine crashes. Also, consider the drill's length to diameter ratio. Longer drills are less rigid and more prone to deflection.
Smart. And the final piece of the puzzle, precise programming.
This is where the CAM software computer-aided manufacturing earns its keep, generating accurate tool paths, using the right G-codes to tell the machine exactly what to do.
G-codes, like G81 for a basic drill cycle, G83 for peck drilling.
Precisely. Controlling the depths, the retracts, the feed rates, using those CAN cycles efficiently. Good programming ties all the other elements together for a smooth, accurate operation.
So it's really about mastering all these interconnected things: the material, the tool, the speeds, the coolant, the holding, the chips, the monitoring, the code.
That's what takes it from just making a hole to precision manufacturing. Paying attention to all those details.
Okay, so given all this tech and methodology, where do we see CNC drilling machines really being used heavily? Which industries rely on this?
Oh, it's widespread. Anywhere precision, speed, and repeatability in hole making are critical. The article lists quite a few. Automotive is huge.
Engine blocks, cylinder heads?
Yep, engine blocks, heads, suspension parts, wheel hubs. Think of the thousands of precise holes in every single car. Then aerospace. Even higher demands there.
Extreme accuracy, difficult materials.
You got it. Fuselage panels, wing structures, engine components, often working with titanium, high nickel alloys. And the safety aspect means every single hole has to be absolutely perfect. Requires meticulous process control and documentation, not just accurate machines.
Makes sense. What about smaller scale stuff like electronics?
Definitely. Electronics uses CNC drilling for tiny, precise features in housings, for connectors, for mounting holes on PCBs, and related, the medical device industry.
Prosthetics, instruments.
Prosthetics, surgical instruments, implants, often using biocompatible materials, needing incredibly high precision and smooth finishes.
Right, applications where errors are just not acceptable. What about heavier industries?
Sure. Industrial equipment manufacturing, drilling big holes in machine frames, flanges, hydraulic blocks, the energy sector components for turbines, pipelines, oil and gas equipment that needs to be super reliable in tough conditions.
Okay.
Even mold and die making. Those intricate cooling lines inside a mold, the holes for ejector pins, they have to be drilled precisely for the mold to work correctly. And shipbuilding.
Shipbuilding, that's a massive scale.
Huge scale. They use massive gantry-style CNC drills to put all the bolt holes in those enormous steel plates and beams for assembling the ship's structure.
Wow, it really covers the whole spectrum, doesn't it? From microelectronics to massive ships.
It does. And don't forget consumer products. Appliances, smartphones, even furniture parts often rely on CNC drilling to balance cost, speed, and quality.
So everyday items, too.
Yep. And the article also mentions emerging tech automation, robotics, communications, semiconductors, all pushing the boundaries, needing that precision drilling for their innovative components.
So the common thread is just needing accurate, repeatable holes, often lots of them, efficiently.
That's the core need, yeah.
Okay, so let's try and wrap this up. Bringing it all together, the main distinction we've been talking about, it really boils down to focus versus flexibility, doesn't it?
I think that's a great way to summarize it. Dedicated CNC drilling machines, masters of specialized hole-making precision. CNC machining centers, versatile do-it-all machines where drilling is one capability among many, like milling, tapping, etc.
So the choice isn't really about which is better overall.
Not at all. It's about your primary need. Is your main job making lots of highly precise holes as efficiently as possible? Or do you need a machine that can drill, but also mill complex shapes, tap threads, and do other operations all in one setup? Because versatility is king for you.
It really comes down to matching the machine to the mission.
Exactly.
Yeah.
Understand the job first, then choose the right tool.
Well, this has been genuinely fascinating. A really insightful deep dive into CNC drilling. And considering everything we've covered, all the different machine types, the huge variety of drill bits, the critical process factors, it does make you think, doesn't it? For anyone listening, what new possibilities or maybe efficiencies could you unlock in your own hole-making operations if you really drilled down? Sorry, couldn't resist into some of these details. Maybe time to rethink the current approach.
Definitely food for thought.
It is. Well, thanks for joining us on the deep dive.